Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of Cartesian equation of plane. So as per the problem, the three non-collinear points P, Q and R lie on a plane. Using vector PQ and vector QR as direction vectors and point R, determine the Cartesian equation of this plane. So we have to find the Cartesian equation of the plane on which these three non-collinear points lie. The first step is to write the general equation of a plane in Cartesian form. In this equation, A, B and C represent the coefficients of x, y and z terms, and they are also the components of the normal vector for this plane. Now we should find the direction vectors PQ and QR using the given points PQ and R. Let's start with direction vector PQ. We should break up this vector into position vectors for points P and Q. We can use point Q for position vector OQ, and we can use point P for position vector OP. Now we can subtract these two vectors. We should subtract their x, y and z components. 3 minus negative 1 is equal to 4. 1 minus 2 is equal to negative 1. 4 minus 1 is equal to 3. So this is vector PQ. Now we can find vector QR. We can break up this vector QR into position vectors for points Q and R. We can use point R for position vector OR. And point Q for position vector OQ. Now we can subtract these vectors by subtracting their x, y and z components. Negative 2 minus 3 is equal to negative 5. 3 minus 1 is 2. 5 minus 4 is equal to 1. So this is vector QR. Vectors PQ and QR are direction vectors for this plane. We can find the normal vector for the plane by doing the cross product for vectors PQ and QR. Because cross product of two vectors gives us a vector which is perpendicular to those two vectors. So this is a very important concept we need to understand and memorize. Now we can use the vectors QR and PQ. We can do the cross product by stacking the y, z, x and y components of vectors QR and PQ. For vector QR, the y component is 2, z component is 1, x component is -5, y component is 2. For vector PQ, the y component is -1, z component is 3, x component is 4, and y component is -1. Now we can find the x, y, and z components of the cross product vector. For x component, we should cross multiply the y and z components. I get x equals 7. Now we can find the y component, and for that we should cross multiply the z and x components. We start with 1 times 4 minus 3 times -5. I get y equals 19, and now we can find the z component. We should cross multiply the x and y components. We start with -5 times -1 minus 4 times 2. I get z equals -3. So the normal vector for the plane is 7, 19, -3. Now we can sub in these components in the general equation in Cartesian form. So A is 7, B is 19, C is -3. Next, we have to find the value of D. For that, we have to use the point R. The point R is -2, 3, 5. So we should sub in x as -2, y as 3, and z as 5 in this equation and solve for D. Now we can isolate D by subtracting 28 from both sides. I get D equals -28. Now we can sub in this value of D in the equation, and we get so this should be the final answer for the Cartesian equation of this plane. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.